This is Jeremy Clark of JeremyBytes.com, and over the next few videos, we'll be taking a look at Lambda Expressions and LINQ in C#. Today, we'll be looking at the basics of Lambda Expressions, including the anatomy, some of the syntax, and also captured variables. Now, we do find Lambda Expressions in a lot of different situations, including LINQ, Language Integrated Query, and again, we'll be spending quite a bit of time on this. We also see them when we're dealing with the built-in delegate types, func of t and action of t. If you want some more information on delegates in general and func specifically, you can check out my other video series, C# Delegates. Another place we see Lambda expressions is in callbacks and event handlers. Now the problem is, the first time we walk up to these things, we have a general idea of what's going on, but it's not until we get to the specifics of what Lambda expressions are that we start to really understand this. Now, Lambda expression is simply an anonymous function. This lets us use Lambda expressions as delegates in our code, and we're going to see quite a bit of that as we go along. Now, when we look at a Lambda expression itself, there's just three parts to it. On the left-hand side, we have the parameters, and this could be 0, 1, or more parameters. Then we have the equals greater than sign. This is the goes to operator, and it's also known as the lambda operator. Then on the right-hand side, we either have an expression or a series of statements. Here's an example of an expression lambda. And we can see we have a parameter of type person that's also called person. Then we have the goes to operator. And then we have an expression that will evaluate to either true or false in this case. Now, a statement lambda does not return a value, but it does perform some type of work. So in this case, our parameters are object sender and event args. Then we have the goes to operator, and then we have a series of statements that perform some type of work. Now, one great thing about Lambda expressions is they have a lot of syntactic sugar that we can add to them to make our expressions very, very compact. This also happens to be the thing that throws people off when they approach lambdas for the first time. Now, the first thing we talk about is how we name parameters. It's very common to use a single letter for parameter names in Lambda expressions. This is not required. We can name our parameters whatever we like. But because Lambda expression syntax is usually so compact, we'll use single letter parameter names just to try to keep things short. But now let's take a look at a few of the syntactic variations that may make Lambda expressions a little harder to read, but they are very useful. The first is called parameter type inference. What this means is that if the compiler can figure out the types of the parameters, we don't have to put them in. So here we see our parameters s and e without any type specified. Now these are still strongly typed. The difference is the compiler can figure it out, so we don't have to type it in. Another variation is that parentheses are optional when we have a single parameter. So in this case, we just have one parameter e all by itself, and because we just have the one parameter, we don't need the parentheses around it. This is very common to see, especially when we're looking at LINQ methods. Now, to make things even shorter, if we only have a single statement, the curly braces around it are optional. So we can see that a combination of single character parameter names, along with parameter type inference, along with no parentheses around a single parameter, along with no braces around a single statement, creates a very, very compact syntax. Now there is one other variation, and that is if we have no parameters at all, we just have a set of empty parentheses where the parameters normally go. This isn't very common when we're talking about LINQ, but it can be common when we're talking about delegates with other frameworks. So now that we've seen some of the syntactic variations, let's jump over to the code to see this in action, and also take a look at captured variables. So here we are in Visual Studio, and let's take a look at this project by running it to start things off. So here we can see on the left-hand side, we do have a number of UI elements, including selected item, a space for some filters, and a way to order our data. Then down at the bottom, we have a refresh button, and then on the right-hand side, we have a list box. Now, if we look at the code behind for our form right now, we'll see it's not filled in. Right now, all we have is a placeholder for our buttons click event handler. So to start off with, let's take a look at where we'll be getting our data. Now in our scenario, another team is providing a library for us, and what they've done is they've provided a class called people repository, And this is providing data using something known as the event asynchronous pattern. Now, when we use the event asynchronous pattern, there's basically two parts to it. We have an asynchronous method call to kick things off, and in this case, we have something called getPeopleAsync. Now notice this returns void. That's because as soon as we call this method, it will return immediately, and our application will continue processing. Now what we see next is that we have an event called getPeopleCompleted. This event will fire after our asynchronous process is completed. So in our code, we'll just hook up an event handler to getPeopleCompleted, and then when the data comes back from our library, that event will fire and we'll be able to get the data out from the event args. If we look at the getPeopleCompleted event args, we see it has a result property, and this is an IEnumerable of person. And if we take a peek into our person class, we'll see that this is a very simple class that just has 4 properties: a first name, a last name, a start date, and a rating. Now to use this library, we'll start out by just hooking things up the way we normally would without Lambda expressions at all. So for this, I'll just create an instance of our repository, and we'll go ahead and call it repository, and we'll new up people repository. And then if we say repository.getPeople, notice that we have both getPeopleAsync and getPeopleCompleted. So that's our asynchronous method call, as well as the event we need to hook up to. Now when we use the event asynchronous pattern, we actually want to hook up the event handler first. That's because there's a very slight chance that our event will fire before we've had a chance to hook up the event handler. So if we hook up the event handler first, we won't have to worry about that. Now I'm going to let Visual Studio do all the work for me here. So I'm just going to say plus equals, and notice Visual Studio offers to create an event handler for us. So we'll press tab, and it gives us a chance to rename it, but I'll go ahead and keep this and just hit tab again. Now inside our event handler, we're going to want to use the result that's coming out of our event args. And notice result is an IEnumerable of person. What that means is that we can directly assign this to our list box. So we'll just say personListBox.itemSource equals e.result. Now the last thing we need to do is kick off our asynchronous process. So we'll say repository.getPeopleAsync, and again, that will fire off our asynchronous process. When that process is complete, the event will fire, and our repository_getPeopleCompleted method will run. So now if we run our application and click the button, we'll see exactly that. So we do have data in our list box. Now as another feature, if I select an item in the list box, such as Dylan Hunt, we see that the selected item is populated in the upper right-hand part of our screen. And we can see as the selection changes, our selected item will change as well. But notice what happens when I click the refresh button. The selected item goes away. And this makes perfect sense when we look at our code. In our event handler, what we're doing is we're replacing the contents of the list box every time we click the button. So the list box doesn't know it's actually getting the same data back, so it discards everything it has and reloads it with the data that we give it. And part of that process is discarding the selected item. Now what we have here is known as a named delegate. When we hook up our event handler, we're hooking up a named delegate, and that delegate's name is repository_getPeopleCompleted. Now I talked about how Lambda expressions can be used to create anonymous delegates. Let's see if we can do that ourselves. So what's an anonymous delegate? Well, it's just a delegate without a name. And to create an anonymous delegate, what we'll do is inline the code for our method. So I'm going to highlight the parameters as well as the method body, and I'll just do Control-C to copy. And then up here where we're doing the assignment, instead of assigning to our named delegate, I'm just going to use the delegate keyword and then paste. And so what I've just done is inline this method. Now we can see Visual Studio's not very happy with us now, and that's because of the names of our parameters. We already have something called sender in the same scope, and the same is true for E. So what we'll do is we'll just rename our parameters. So we'll call this repo sender, and then we'll call this repo args. And then we'll need to rename this to repo args as well. So now we can see that Visual Studio is happy with us. So what we've just done is we've moved from a named delegate to an anonymous delegate. In fact, I'm going to comment out our named delegate so that we know it's not being used. And if we run our application, we'll see that we get exactly the same results we had before. So when we click the refresh button, we do get data. And if we select an item and click the refresh button again, that selected item does go away. Now we said that Lambda expressions can be used as anonymous delegates. Well, we have an anonymous delegate right here. That means we can change this to a Lambda expression. All we have to do for this is delete the delegate keyword, and then in between our parameters and method body, we just need to add that goes to operator. Now we have a Lambda expression. And just to show that things still work, we'll go ahead and run our application, and we see we do still get data populated. But now that we have a Lambda expression, we can start taking advantage of the syntactic variations. The first one that we talked about was parameter type inference. That means that if the compiler can figure out the types, we don't have to put them in. So notice I can actually remove sender and get people completed event args. Now these are still strongly typed. If I hover over these, we see that repo sender is still of type object, and repo args is of type get people completed event args. Now the reason we're allowed to do this is the compiler can figure out the types of the parameters. Why? Well, it's based on this get people completed event that we're hooking up to. Because this is an event handler, the only methods that we're allowed to hook up to this have to have two parameters, one of type object and one of type get people completed event args. And we can see this by trying to add a third parameter. So if I try to add a third parameter, we'll see that we have a very small red squiggly, and when we build, we will get a compiler error. And we can see that our error message says, delegate does not take 3 arguments. And then of course, if we try to use these parameters inside our code, like repo args, we'll see that it does have a result property, which is what we expect from get people completed event args. And in this case, it has the 4 standard methods that all objects have. Now, if I wanted to make this code shorter, I could change these to single character parameter names. I'll go ahead and leave the parameter names that we have here. When we look at LINQ later on, we'll start using those single letter parameter names. Now, another thing that I could do since we just have a single statement is I can get rid of the curly braces. And this will still work exactly the same way that it did before. So if we run our application, we'll see we do get data. And if I select Isaac Gampu, we'll see we have our selected item. And then if I refresh it, our selected item is cleared. So our behavior is exactly the same as we had when we had our named delegate. Now in this particular case, we are going to have some more code, so I'll go ahead and put the curly braces back in. So now that we have the basics of our Lambda expression in place, let's try to fix that selected item problem that we have. So again, the reason why our selected item gets cleared is because we completely replace the items in our list box. So let's think about how we would fix this in code. If I wanted to maintain the selected item, what would I do? Well, one thing that I could do is save off a copy of the selected item before I refresh the data. And then after refreshing the data, I can go back in and see if I can locate that item in the list box. So let's go ahead and do just that. So in our method, I'll create a variable of type person called selectedPerson, and we'll assign this to personListBox.selectedItem, and then I'll say as person. Now when we use as to do a cast, if for some reason selected item is not a person, this will just return null rather than throwing an exception. And in our case, null is perfectly fine because we may not have a selected item. So now that we've saved off this selected person, let's use it inside the body of our Lambda expression. So again, I'm putting this in after we refresh the items in our list box. So the first thing I'll do is I'll check to make sure selected person is not equal to null. And if it's not null, I'll go ahead and loop through all of the items in our list box. So we'll say for each person in personListBox.items, and then I'll check to see if the current person matches our saved item. Now, unfortunately, I don't have a primary key on this, so we're going to have to do it based on the first name and last name properties. So we'll say if person.firstname equals selectedPerson.firstname and person.lastname equals selectedPerson.lastname, then we know that we have the item that we want, and we can go ahead and take our person list box and set its selected item to the current item in our iteration. So let's go ahead and just review this code one more time. So again, at the very top, we're saving off a copy of our currently selected item. And then inside the body of our Lambda expression, we set the items in our list box. And then if the selected person is not null, we'll go ahead and loop through all of the items in our list box, and we'll try to find an item that matches based on the first name and the last name. If we do find that item, we'll go ahead and set that as the selected item in our list box. So now let's go ahead and run our application to see what we have. So if I click the refresh button, we'll see that we do still get our items populated. And if I click on Dylan Hunt, we see it is the selected item. And if I click the refresh button, we see that Dylan Hunt is still the selected item. So we are maintaining that selection when we refresh our data. Now the code we have looks pretty straightforward, but it is a little bit deceptive because I just took advantage of a feature of Lambda expressions called captured variables. Let me show you what I mean by that by putting a couple breakpoints in here. So I'm going to put a breakpoint here, as well as a breakpoint here. Now when we run our application, the first time through, I'll go ahead and just skip over these breakpoints since we don't have a selected item. And then I'll select Dylan Hunt, and we'll click refresh again. So let's go ahead and step through this code. And for this, I'm going to be using this button, Step Over, which is F10. So the first thing we do is we save off our selected person. And if we look at this, we see that it is populated and it does contain Dylan Hunt. Then from here, we new up our repository, and then we hook up our event handler. Now notice this entire section is highlighted. That's because we're simply doing the assignment. We're not actually running the code in the body of our Lambda expression at this point. And then if we keep going, we call getPeopleAsync, and then we hit the bottom of the method. Now this is where things get interesting, because if we look at our selected person variable, this is a method level variable. What normally happens when we hit that bottom curly brace of our method? That means that variable goes out of scope and it's eligible for garbage collection. But that's obviously not what's happening in this case. If I go ahead and run from here, notice now our breakpoint just hit the body of our Lambda expression. That's because that long-running process has returned and that event handler has fired, returning our data. Now if we step through this code and we get to the selected person variable, we'll see that it is still populated, and it is still populated with our value of Dylan Hunt. That means that we can start looping through, trying to find that item, and if we do find it, we'll actually set the selected item. So how does this actually work? Well, again, that's a cool feature of Lambda expressions called captured variables. This actually works with anonymous delegates as well. Inside the body of our Lambda expression, we're allowed to use any objects and variables that are currently in scope when we do the assignment. So since we're assigning our Lambda expression inside this refresh button _ click method, we actually have access to all of the method level variables, including selected person. And if we wanted, we could even use the parameters object sender and routed event args-e inside of our Lambda expression. Now other languages refer to this as a closure. And what's happening is we're grabbing a reference to that variable, not letting the garbage collector collect it, so that we can use it in the body of our Lambda expression, even when that Lambda expression runs later on after this method is completed. Now you might say, what's the big deal with captured variables? Well, the really cool thing about them is they let us scope our variables appropriately. So let's think about how we would do the same functionality if we were still using our named delegate. So remember our repository _ getPeopleCompleted method? Well, that would mean our selected person variable would actually need to be a class level variable. That way it would be available inside refresh button _ click so we could do the assignment to that variable. And then it would also be available in repository _ getPeopleCompleted so that we could use that to try to find the selected item. But because we're using a Lambda expression, we can capture that variable and scope it more appropriately. With a class level variable, technically anything else in our class would be able to update that variable or read it. But when we use a method level variable, it's only accessible within this method itself and not to other members of the class. Now there is one important thing to understand about captured variables. The value of the variable is the value at the time it's used, not the value at the time that it's captured. Let me demonstrate this. What we'll do is we'll change the value of our selected person variable. So at the bottom of this method, I'll just set it to null. So now let's step through the code again and see what happens. And again, the first time through, we'll just skip over it since we don't have a selection. This time I'll select John Crichton and click refresh. Now as we go through this, we'll see that our selected person is set, and it does have a value of John Crichton. And then when we do the assignment to our Lambda expression, this is where we're actually capturing the variable. And at this point, selected person is populated with the value of John Crichton. But then we run getPeopleAsync, and then we set selected person to null. So if we check the value now, we'll see it is null. Now when we run and the body of our Lambda expression runs, we'll see that when we get to the part where it says is selected person null, we'll see it is in fact null. So we can see the value of the variable is the value at the time it's used, not the value at the time it's captured. And if we keep running from here, we'll see that we have no selected item set. Now in most cases, we don't have to worry about this. Generally, when we have a captured variable, we're using it pretty locally and we're not changing the value of it. There is one exception where you can run into trouble, and that's if you capture the indexer of a for loop. Now I won't go into the details of that right now, but we will be taking a look at that a little bit later on. In the meantime, if you check the links for this video, you will find a link to an article that shows an example of trying to capture the indexer of a for loop and the really easy thing that we can do to get around the problem. So today we've seen the basics of the Lambda expression. In this case, we're using a statement Lambda that we're hooking up to an event handler. And again, we have a very simple signature, so we do have our parameters, then we have our goes to operator, and then we have the body of our Lambda expression, which again is a series of statements in this case. And we did see how parameter type inference works. Because the compiler knows the types of our parameters, we don't actually have to type them in. So instead of having object repo sender and get people completed event args, repo args, we can just have the names of our parameters. And we also saw how captured variables work. So in this case, we had a method level variable selected person, which was in scope when we created our Lambda expression. Because of that, we can grab a reference to that variable and we can use it in the body of our Lambda, even when it normally would be out of scope. So that's it for the basics of Lambda expressions. We got to explore the syntax a little bit, and we got to see captured variables, one of the great features of Lambda expressions. In upcoming videos, we're going to take a look at LINQ, Language Integrated Query. We're going to see some really cool features. We're going to learn how to understand the syntax of the LINQ methods, and we're also going to see how Lambda expressions play a key role in our LINQ methods. And as we'll go, we'll see some differences between imperative programming and declarative programming. Sounds like a hard topic to understand, but it's really not. LINQ is one of my favorite features, and I love using it in my code. So until then, be sure to visit www.JeremyBytes.com for more information, and we'll see you next time.